live stream here about the current unfolding coronal mass ejection. But before I do so, I would like to say, see ya! Alright, you're out of here. Later. Alright, so we see a little bit of, oh, and by the way, I think I'm retiring the glasses possibly forever for reasons which are classified. Anyway, we're going to talk cosmology here for a quick moment in the form of coronal mass ejections. So for everybody who's studying astronomy and cosmology and not understanding the sun's behavior, there are problems. Deep, deep problems. Because if you think you understand how to calculate the mass of a distant galaxy, perhaps consider the calculations used to figure out the mass of the sun. It's let's just say it's a problem. So, first thing I'm doing here is I'm just showing a 48-hour movie here of what some people call Sol, or the sun, aka the local yellow dwarf. And what's the point? The point is, if you know how this works, perhaps you know how all stellar stuff works. Maybe you can figure out and extrapolate how things operate in other galaxies. But when your fundamental understanding of that is confused, then, again, there are problems. So, again, we're streaming live to Twitch right now. For those of you who haven't checked us out on Twitch, it's twitch.tv/smAsho. And let me just bring up the my epic pen here, because we're going to be looking at a view from Stereo A. So Stereo A is a spacecraft that is trailing the Earth as it orbits the Sun. The Earth orbits the Sun in this fashion. The Sun rotates in the same fashion. Mercury goes the same way, and so does Stereo A. It's at Lagrange point 4. I think it's 4. But anyway, it's at a gravitationally stable spot. It just trails the Earth, maintaining the same distance. So what we're going to do is we're going to look at the image from a coronagraph in this direction. Before we do that, let's look at what this looks like from Earth. So the spacecraft in between Earth and the Sun is going to show you this sort of a view right here. This is the SOHO spacecraft, and that's at Lagrange point 1, directly in between the Earth and the Sun. And you can see there already is a bit of a halo. As you can see, coronal mass ejection on both sides. But the main coronal mass ejection has yet to happen. So this is why we're keeping an eye on this, as we're developing a system to figure out what the speed of it is. And I can't really divulge how that's done, but it's interesting. And I would again note that what we're seeing here is not the main coronal mass ejection that's Earth facing. So let's go to the view from Stereo A instead of here in between the Earth and the Sun. And here's what's going on from that perspective. Now, important thing to understand is that the Earth is off in this direction on the ecliptic plane. That's the plane on which planets orbit the Sun. And you can see right in this area there's a fairly large ball of plasma about to head down the pipe. It's similar to what's going on over here, actually. So you can see the way that's ejecting right there. We have a nearly symmetrical coronal mass ejection. So this is a great opportunity to study the way these things propagate. and I thought I'd share with our viewers. Now I want to go look at the LASCO C3 as well as the C2, and you can see a halo coronal mass ejection there. And when you see plasma coming out of both sides like this, as we do here, that's typically because of an Earth-facing coronal mass ejection, but we don't see that quite yet, because on this side, keep in mind, SOHO is viewing the sun from this sort of a perspective, and what SOHO is actually picking up is this plasma over here, not this, because this is still propagating. So this is a great opportunity for some additional analysis, and by the time we do our daily space weather video tomorrow, this will be legit. I want to bring up one more thing here real quick, and then I'll end this stream, because I just want to see what the magnetic field force lines appear to be doing. So let's break out the high-res 304 angstroms view. And there you can, not surprisingly, see sort of a lack of field force lines. And that's an indication that there is plasma on the way. No surprises there. How about a high-res image of the colorized magnetogram? And then we'll close this mother out. And there's what's going on in the colorized magnetogram. And don't be surprised if you see a little blurriness in this. Keep an eye on the Stereo A Core 2 Space Weather Beacon. And the way you get to this is if you type in integrated space weather analysis into a legit search engine like DuckDuckGo.com. You just click on that, right? I just searched for it. And that'll start you out on the Solar tab. From the Solar tab, click on page 7. And the first entry on page 7 is the Stereo A Core 2 Space Weather Beacon. Just click on that. And what we typically show on the channel here, if you want to monitor this yourself, you just click on Movie. And then you come over here, and I always do 100 frames before present at 20 frames per second, which is the maximum. And that's there's the current data on that. Some of the data on the space weather analysis setup, the integrated space weather analysis, the ISWA, some of the data is anomalous and not appropriately coded, and some of the data is not even current and cannot be accessed. For instance, Stereo B has sustained some damage and is only returning things like magnetometer data at the current time. So anyway, keep an eye on this area, and when I say eye on, the pun is intentional, as you live out in this area. And while this isn't a major coronal mass ejection of any really importance, it's not going to be super big no matter what happens. It won't have any really capability of doing any sort of real damage, but it provides an excellent opportunity to compare its similarity to this coronal mass ejection. So there is a way to meter these things, and we're not going to get into it because this is just a quick update. Thanks for tuning in. We are out, and don't forget to get rid of that, and stay tuned for some more content coming soon. And may the solar wind be at your back.